Okay. Wow, isn't this wonderful? I got a big, hot loaf, smelling cheesy. So, today I'm going to do something a little bit different, but still working on the same thing. I've just been kind of porting the algorithm uh, that is doing a physics calculation. And I got to the point where I could run it, and it does not work. It just does not work. So, my idea to try to solve that is to spin up the Lua code that I'm copying and compare the values at every step of the procedure and see where it's going wrong. Um, and this shouldn't actually be that hard, assuming I will need to like do a vector library. Hmm. Hmm. Holy. The bread, the it's like I guess I can like it feels like I don't know like a bag or something where like the crust is like it'll freely warp on the inside, but there's a skin on the outside. Instead of just being hard bread, it's like fresh bread. I don't know. Maybe that's kind of obvious. Yeah. So I may alter the Lua code so that it like uses the Lua vectors, the SIMD vectors that are part of the standard library, instead of needing vector 3 library. But does it have like dot products? It must. It must. Standard library. Yeah. Hmm. Hmm. Fresh bread cannot be beat. Hmm. And butter? Oh. Is this legal? Mm-hmm. Mm-hmm. Yeah. I have example code. I've written it before to like run arbitrary Lua scripts. How's the coffee gonna be with the bread? Hot and sweet. Not the best pairing. Mm. Usually I like to eat off stream. Cause like I don't know, just not always the biggest talk and eat person. Especially talking to myself. Talking to my imaginary friends. Oh. Maybe I should like just get to work. And then just like every once in a while, take a little snack. So I can start right now. Oh, I see. I don't buy anything else. This is Asiago ciabatta bread. They put the cheese on the bread. Well, hopefully I don't. Oh, it kind of already is crummy. Get my setup too crummy. Oh yeah. Right. Um. Hmm. How's this gonna look? Okay. Basically, what I need to do, I think it's in here. There's this function called contains point here. Excuse me. That's going on. Basically, what I'm gonna want to do is run the Lua version and run this version. So I'll be like, run Lua version right here. I don't think it'll take more than an hour or two. I'll just like unwrap. Alright. Oh. You're gonna talk about it. Okay, so I have my like little changes here. Yeah. So, if I get rid of this. Oh. Eek, partial eek. Real? Last point. Oh, okay. Um. Eh. Yeah. Okay, and then this is bake. Good, and then new branch, create branch called Luau. Ooh. And then I think what I'm gonna do. Cause it's not like there's a bunch of Lua, right? New file. I'm just gonna call it minimum difference. Lua Rust. Lua Rust. Together at last. So mod minimum difference Lua. And then oh. We go to here. Engine. Ooh, StrafesNet. Oh no, it isn't here. Engine, physics, ER, cargo. Add MLUA. Yay. Features. Wait, Luau JIT. What? Not available on many platforms. They literally, it's literally only not available on Apple. That's it. It's just Apple is schizo about it. That's corporate speak for we don't want to offend Apple. Which, like, fair, but oh no, the developers, they're gonna compile things. This is a I mean, I guess it's not insane. It's like conservative for sure. Like the basically I think where it comes from is like web browser jitting, where it's jitting the JavaScript. Probably the browsers have like a special permission to be allowed to do this, because that's how browsers are fast. And there's like numerous security vulnerabilities coming from like just C++ code that's jitting. JIT is just in time compilation. So it's turning some JavaScript code into some machine code to execute to make it faster. And it does that just before it runs it. So it's like, oh, it looks like the program is doing this. All right, I'm going to compile a little function that just does specifically that in machine code. And that is a huge source of security vulnerabilities. So it's not insane, but it's extremely conservative in terms of like what you allow on your platform. Yeah, so that's Apple. Ahead of time compilation would only for code that Roblox ships. What? Oh. Oh. Wait. Optional JIT component. Holy. Who made this? Okay. So this is like one of the strongest suits of JIT compilation. And in fact, in certain cases, JIT compiled interpreted languages can end up being faster than a compiled language, because the JIT compiler can trace the actual code that's being executed and optimize for that path rather than guessing based on heuristics like, oh, as the compiler, I think that this path will be the hot path. Is there a way to fully reset keybinds? Can't move now. You can try setting your camera sensitivity. Keybinds reset every time you rejoin. So, yeah, they actually are quite lacking in terms of persistence. Keybinds are not persistent. Yeah, that could use a UI. You go complain to Tommy and Aiden. Surely they'll make it. Oh, I actually like that coffee flavor. But it's just cream and sugar. It's the spell that makes all coffee taste the same. Sometimes it's good, I guess. Portable bytecode interpreter. Oh, this is really good bread. The fresher, the better. While extra performance can be extracted by rewriting the interpreter in assembly, we're unlikely to ever do that. Bruh. Rejoin it works? Nice. Better bytecode design. But doesn't come close. XD. Mike Hall. Damn. Core loop. 16 kilobytes. It's pretty hot. Multi-pass compiler. Parses into AST. And back in that generates bytecode from this is like an entire compiler. Small penalty in terms of compilation time. Compilation throughput isn't the main focus. Deep constant folding across functions and local variables. Holy. All right. I gotta actually do the work. There's a quite big windows in the back. Cool view. Yeah. That's this apartment was unlike any of the other places I looked at. I was looking at places with fast internet, and just like there's this kind of house place. There's a place over there. Looked at a few places, and this place, it's like up in the sky. It's got a gorgeous view. The price is low. It's centrally located near. It was just, oh my god! It was just leaps and bounds better than all the other options. Such an obvious decision. do not regret living here. I used to have a program where I could like stream from my phone and show it. I wonder if I can get that to work. Oven player media. Where are the real search results? What am I looking at? Do I need to freaking like sideload it? All right. Basically, I could go stream to my server, and then from my server to OBS would capture. It would like send the video to OBS, and then I could just like show what I'm saying. I don't think I can actually do that right now because my streaming server is not functional. It really really doesn't want to work. Yeah. Yeah, I don't think I can show you. You know what? I got an idea. All right. Here we go. Screen. There it is. Wow. You can see the camera and the reflection. Yeah, so nice view. Really high up, and there's no buildings in front. Amazing. There's 3 cities on the horizon line. I remember one day. There was this fog beneath the building, so like out the window is beneath this building, and the fog went all the way to the horizon line, and then you saw like floating cities on the horizon. That was really cool. Bread. Yes. Cheese bread. I'm not doing a lot of writing code at the moment. Mostly because I'm reading and eating bread. Why don't I just keep reading and I'll just put the bread away after this. Yes, okay. Okay. Meta tables, yes, that makes sense. So it can't optimize a times 1 because a might be a value that has a meta table that says when you multiply, do something else instead of just like normal multiplication. Makes sense. Up value optimizations. Up values that aren't mutated. Nice. Is that, can it also do like aliasing? What's this? Improve the performance of a small set of instructions by replacing them with more efficient alternatives without changing the output. Okay. So it just draws a box around the code and it says, that code, I know that this code is better and does the same thing. Okay. That seems like extremely obvious to me. Oh, wow. Okay, they're describing a security vulnerability right here, I think, and I don't understand it. It might be reasonable to assume that in presence of known types, what is that? We confer absence of side effects for arithmetic operations. If the runtime types mismatch due to intentional violation of the type safety through global injection. What is global injection? Do they mean literally using global values? And like some function over here just goes like G safely sandboxed. Okay, does this mean that they switch from the compiled version to the sandboxed version and it instantly gets slower? Holy. What is that? Is that like how you allocation that moves memory allocation statements outside of loops? Oh. Number. Really? That's something that I do. Have fun streaming. I'm glad you could fix your problem. You're not obligated to stay. See ya. Uh, fresh bread has been sufficiently taken advantage of, which is what I wanted to do. Great success. I love syncopation. Song is this? Okay. Moving the cheese bread to the cheese bread storage, deep storage location. I think I have an idea of why the coffee tastes better. I think it's because of the fresh cream. I just bought it. I was actually just using expired cream yesterday. Used up the last of it. Oh yeah. Okay. So it shouldn't be that crazy to just kind of bring up the entire Lua VM. So we got a little emulator. Runner. Yeah, init. Sandbox true. No way. So who called that function? Lua new. Alright. Yeah, okay. Okay. Here we go. Public function, minimum difference. I need the same function signature. Boink. Lua new. Can this fail? Generates a new Lua state and loads the safe subset of the standard libraries. Okay. 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 Yeah, I can just do that. That should work. Alright, Lua. Function does not exist. True, so true. So I can make this not a public function, and then just like call this function. Use mlua result. Yep. Bool. Okay. I think I'll make a little initialization. Yeah, okay. Init Lua. Yep. You go over there. Result real, and then Lua like this. Oh, very true. Okay. Cool. Okay. Globals. I don't think I need to set this up. So init new runnable context. I don't need all this crap. I think I can literally just run it. Boy. Okay, what does it do? It says local function, return. All right. Right. Uh-huh. Oh, I'm calling these debug.profile begin. I wonder if that's in the center library. We'll see, I guess. Oh my god. Okay. How slow is this? Probably. It's probably not that bad. I could just. I mean, like, it's literally just a check. Like, I don't need it to be high performance. I can just have it lock up the game every time you press R, just so I can see the debug information. It just literally does not matter. I can do it. I can do it. Okay, so init Lua. Okay. Is this default? Only count mode. Oh. Oh, clear changes made in Sandbox. Weird champ. Okay. Okay, read only. Okay. I see, I see. Proxies reads. Interesting. Okay, thinking. I need to actually read the script. Where, how, who did that? Create thread. Thread resume. So I know you can like make a. There it is. Lua load source. Yes, sir. We do like this. Lua load source into function. This is the type of situation I'm about to do. Lua load source. Insane. Okay. So this makes a F Lua function. Alright, I'm just gonna like make a little goobert here. CTX Lua Lua hoi, and then F Lua function. What? Oh, it's mlua. You goobert. Okay. So this is not real. We can do this. Let source equals include bytes. Include stir. Find the file. Help. It's gonna be home quat strafesnet game source replicated storage shared freaking tray minimum difference dot lua. Situation is that is what the situation is, and this let's go. Okay, source and the name is this guy. We're just gonna call it that. Yay. Okay, so now we're returning this CTX thing instead. We got a Lua and we got F. That's the situation. What's the situation? I'm actually curious what the performance of this function is, but like it literally just does not matter. Okay. Can you just F it? Can you be like, oh, F, and then you're good? Create thread, resume. I just want to like call a function, like, you hear? So, so we go like, it's not a result bool, it's a result, someone else. Details? Do I want details? Okay, I think I have a way. Struct minimum difference. We have hits is bool. And then we have details. Option details. We can actually grab that from this. These are the details. Right here, right here, right here. This is not real. F32 freaking mlua vector. Yeah. Oh. Is this a F64? It probably is, isn't it? Okay, so we want result. Like that. That is our result. So we go like equals to init lua question mark semicolon. And then we do ctx.f call definitely surely. Okay, what's the function? Minimum difference. Okay, so there is several function argumentatives. Struct. Input tuple. Maybe it'll take a little bit of work. Haha. Gobbly gobbly gawk. So loud. Right. So we can just do this guy from Lua, and that's chilling, right? So this is the old output. Yeah. Can I quick R. Wow. Wow, the traits are crazy. I think I can literally smack this right there and we're done. I need to copy the function signature. Like this situation. Are you allowed to snag these? Yeah. What? It's gonna be some work. But I think I can make it. I can do it. Naming things. Trait bounds. Um, M Lua vector. I think I should actually just go PV3 here, because this is the result. From Lua multi. Yes, sir. For is there a freaking no minimum difference? Yeah, man. Yeah, dude. Yeah. Results self. Do you have to match? I don't remember how to do this. How do you like grab it? Oh, it's literally right. I forgot. Okay. From Lua multi. So are we doing? I think we're doing match values as. Oh. Make contiguous. Oh, it's not mutt. Yeah. Can I? Am I allowed? Mutt. It's mine. You're mine. Okay. So we have several values here. We got mlua value the Boolean. I know this function also can return nil, which is a little bit gooby. Boolean hits. Hits. Details. None. And I can say okay on this. Pretty nutty. Expected mutable reference. Oh. Yeah, and then anything else, unlucky. Error, mlua. Error. Whatever. What do I do over here? Error Lua. Huh? Oh. I know there's going to be a lot of errors in here. Error. mlua. Error. Runtime. All right, buddy. What is S? Display. Interesting. Okay, so invalid return values. So there's several values here. There's also nil, I guess. Invalid. Nil. Whatever. Okay. Yeah, it should be almost exactly the same, except a massive list of values, basically. Okay, so we got a value that's a Boolean. We got a value that's a number. A value that's a vector. Oh, give me. Right. And then we say details is details. And we should actually be able to just kind of smack this straight in, right? No, I need to convert. Can I do into? Yar. Get this. Berta into. Oh, it's option. So true. Some. You know what? I'm going to expand this a little bit. All right, so you are F64 and you are a F. Is it try into? Holy. Okay. Well, I'm going to need a conversion function here. I can't just use into. I did implement it for the floaty boy, but we have vectors here, so. Function. P64v3. Sure, I'll just call it that. Value mlua vector real it's gonna be a fixed from float error. Yes, sir. Okay. Do I have v dot x? Okay. So we do v3 new. Hey, can you like give me the real? Can I have the functions? New. Hello? Do it. Jesus. Okay. V dot x try into question mark semicolon. Almost semicolon. Y Z. Hype situation. Oh. Oh, it doesn't know what this is. Oh, and this is an Uber. Okay. Okay. Lua result. All right. Is this real? It is real. Okay, and this is not real. And this needs... Okay. You good? Okay, we good. Okay, so then here... Unwrap. Okay. From Lua multi minimum difference. Okay, so now the return value of the Lua code will be converted into Rust types. Just like that. Ugh. Oh, so now I need the other way around. Yeah. Snake case. Okay, so this is a goddamn function. I think I'm just gonna do this because like there's gonna be several. Query, radius f64. Exit radius also f64. Test intersection is a bool. Yar. Okay. Ooh. Uh. Args. Let's call this args. Whatever. It's whatever. Okay. Um. Um. I might need a question mark there. Not sure. Okay, so we need two things here. Impl args, function new, with these arguments. Self. Oh, I need Lua as well. ctx.lua. Gimme. You know what? What am I doing? Just Lua, okay? There's Lua. We have Lua. Lua is real. It's a Lua. Lua. Real. Okay. I think my function is going to hold on to this reference and explode and die. That's just what I think. I'll need to do like lua.create function. Calling a function. Mutable closure. Yeah, no, I don't need mutable. Create function. Maybe send. Static. So you see it's static. I know how to fix this, but it's a little bit crazy. Okay, I remember. You're supposed to like Yeah. Okay. I see. I see. I wonder if I could convert the whole runtime model to use external references within the functions by and pretend that they're static instead of doing app data. The app data is like kind of verbose. This is not gonna work, but I can just like pretend and it should be fine. Do I have my extend lifetime function here? No, it's in the runner. Here it is. My unsafe function. You love to see it. XD. Mutt. Do we need mutt? I don't think we need mutt. Oop. Oh, true. Ugh. Ugh. Self. Right, yeah. Lua result self. Yep. Question mark semicolon. So query P equals function type situation. Yeah. Okay. Args. Why does it suck if you like the LSP always spams spaces? It's annoying. Um. Yeah, this is gonna be interesting. Lua. What? There's one argument, right? Option vector. So vector is gonna be an mlua vector. Yeah. Okay. Gotta remember how it works. Very shrimple. So all we do is we say point equals pv3 point unwrap semicolon mesh dot mesh 0. Oh no, is that private? Ooh, we can't be having that. It has to be public. Um, Never mind. I don't actually need it. No, yes, I do. Yes, I do. Because it's the query, they course, yes, separately. Um, PQ. So P is 0, Q is 1, is fartvert point. And then vert. And I do mesh 0 vert. I guess I can call this vert ID. That'll work. And then that gives a PV3, and I do into? No. New. Okay. Oh, v dot xyz dot into. Okay. Option low vector. Oh god damn it. Let some point equals point else semicolon return mesh dot mesh 0 what dot transform. Oh, it's a hint point actually. Hint point and I say vec on this and okay. And then this is a P. And same deal here. Vec point doing doing done. Holy, okay. There's a query function. It is not gonna like those lifetimes. It's gonna scream at me. It's gonna be like, "This is not static. It's not static. It has to be static. It's in the trait bounds." Trust me. Damn. Where did that come from? Okay. Okay. Query P, query Q, mesh 0, mesh 1. Except now we also want to do plus point. God damn it. God damn it. I need everything point. Okay. All right. This guy's getting called P. This guy's getting called P. This guy's getting called B. One. All right. We're doing better off. Okay. So then we do plus point. And that should work. Okay. And then radius. Radius equals 0. P Q exit radius test intersection false. Yeah. All right. So here's the screaming I was talking about. We can use underscore here. Yeah. So what I need to guarantee is that this lifetime is valid whenever this function gets called. So that is until right here after the function call. So effectively, the lifetimes are already good. And I can just like pretend it's static here. So what I do is say static like that. And then it's like, excuse me. Point, which is owned by the function. Point, which is owned. No. Point is borrowed. I don't want to borrow it. Just move that goddamn thing. All right. So then here, mesh. I'm going to do extend lifetime mesh. Mesh equals extend lifetime mesh. Well, this actually doesn't need to be called mutt. Extend lifetime, semicolon, unsafe. So true. Just so true. Unsafe. Absolutely true. Okay. Okay, so I made the new, but not the ooh. Okay, so safety. Mesh lifetime must outlive well, this might actually have trouble because this has its own lifetime, and the lifetime has to be invariant across the reference lifetime. I might have more trouble with this. From the call site, it'll be like, the mesh, the lifetime, Yeah, it'll be fun. Yeah, literally, this must live until like here, and that's it. So should work. Q is different since it includes the test point offset. Query which point the farthest point I guess I could call this dir on the mesh in the given direction. Query period no dir 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 dir. Misnamed variable, as expected. Okay. Continuing. Implement into Lumi. EFGHI. We'll put them together. For args. Yar. Oh. Oh. Somebody's not happy. Oh. Okay. So, basically, I don't think I'll need this. We just go like multi value new from vec with capacity yeah. So these are all Lua-able values. From iter would be kind of cool, but I think I'm going to go for from vec. And we'll go vec, bang, and then we'll go, hey, what's up? I got the stuff. And then we'll go like, self. Haha. Self dot ding dot dung. Into Lua. Question mark. Lua Lua. All right. Real. Right. True, 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 true. Okay. Okay. Yeah. It's a reference that is only valid on the function body, and then meshes case the function body here. Yeah, so it's saying that this lifetime is Scoobert on the Doobert. Okay, I'm just gonna use transmute. I just like, this is for testing. If it breaks, that it's just so not important. Core mem transmute. So we're changing from this to this. Static. Static. Static, static. So we're just converting. We do not care. We do not care. Okay. What about you? Are you calling it? Are you calling me stupid? Contains point is private. Lying? Lying. Why is it private? Right. Actually, um, I want this value. And then here, true. I'm juicing this Lua code right now. Okay, so then I should be able to have a second thing. I'm just gonna tuple. I don't care. Pub struct details pub. Ooh, okay. Yep. We call it that. That hits. This is false. Nd dot details unwrap. Oh, it's not a tuple. Please, please, sir, please, sir. Oh, it's a different function. Okay. Close contains closest point. Yeah. This function. I mean, I think I got it. Cool. That's how you implement a Lua VM. A little bit unsafe, a little bit of transmute. Just to skip the app data boilerplate. It's kind of like moving the borrow checking to compile time. And like I guarantee that this value lives until the end of this function once it stops being used. Okay. So I'm creating an entirely new Lua runtime, converting values in and out. I got these REST function calls. Oof. Oh, I guess I should explicitly state static. Oh, actually, if this is explicitly stated as static, then we know what it is. It's well defined on both sides. Surely it doesn't segfault, right? Surely no UB. Closest point. We could say like minimum difference details. Oh, okay. Did I do it? Holy bool. Oh my god. So we can just say contains point Lua equals contains point Lua. And we're chilling. Okay. Whoa. Lua got updated. Oof. Nice spelling mistake. So I think that the Lua will die instantly. Uh-oh. Oh, is there default features? Where did he go? What happened to the feature? What? Oh my god, I just did something dumb. Alright, yoink. Go away! Alright, try again. Lua sys. Okay, so I think it is going to have a Lua error and crash. That's what I think. But like, yeah, because it's using vector 3 f vector 3. All right, why don't I just kind of like luau vector dot create. Cool. All right, that function exists. Vector dot 0. Amazing. Vector create. All right. We go again. The file gets embedded when it compiles. Okay. Good luck to everyone involved. I expect it to just crash. Okay. Invalid return values. Wow. Okay. So it initialized a new Lua environment, created a compatibility interface to interface with the Lua code, ran the Lua code to completion, got the return values, but then failed to convert the return values back into Rust. What am I looking at? here. So that is right here. So I put underscore. I'm just going to debug a type situation. Oh. Format. Let's go. Okay. We go again. Tell me what the values are. Table. Oh. Okay, I'm dummy. The Lua code is returning a table and not a function, and that's my mistake. Fair, fair, fair. Yar. So down here, I do into function, but it's table chunk into function. Function. So why don't I call this like lib? Call. Empty tuple. Question mark, semicolon, table. Never. Oh. Oh. Okay, this is not a lib. This is lib. Lib mlua table. And then lib get right. Difference. Question mark, semicolon, let f equals real. How does it know? Value ref Lua weak Lua. So every single value knows what Lua it belongs to. Yeah. 24. 8 plus 8 bytes, man. Damn. But I guess you gotta do it. Okay. Try again. So I just forgot to like get the table out and then get the function out of the table, and then that's the function. It's not immediately the function. Okay. Attempt to call a nil value 605. 605. Wait, that's in the script? 605. Oh, debug profile begin. Gah. Index vector with magnitude. Really? You can't do that? Is it capital M magnitude or something? Is it a goddamn function? Lowercase dot. Whoa. Attempt to index. Are you allowed to do that? Member function? Is it gonna say this for every single one? Like, do I need to go through and H this? Index. Okay, so it's just not gonna work. It doesn't have self things. Manual labor. Oh my god, bro. Okay. Vector 3. Oh, vector dot 0 dot magnitude. So I have to do vector dot magnitude vector dot 0. Oh, wow. And then dot. And there's dot. Okay. Vector dot magnitude. I'm just doing this off screen because it's actually private code. Oi, 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 oi. Okay. damn dot products. Yeah. Dot 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 dot, and that's all I can do. All right, so we do backspace, Control Shift back, Control X, vector dot dot over, boom, boom, space, done. Vector, I mistyped it. All right, and then cross, yeah. Vector dot cross up, vector dot cross. I'm doing this because I don't want to load a goddamn library. Okay. Ciao. Backspace, Control Shift X, vector dot cross V comma boom. All right. So then this one, comma, vector cross, vector dot unit, vector dot 0. Is it normalize? Nice. Okay, vector dot cross. Let me just read these nested function calls. Vector dot norm. Oh. Dot dot dot. Alrighty, righty. Ay, ay, ay. 14, please. Oh boy. All right, how we doing here? D, 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 D. Nice. All right. Backspace, Control, vector dot magnitude. All right. Try again. Cross dot. Uh-oh. There's some dots left over. Oh. Didn't quite get them all. Go again. Nice. How long did that take? 2 hours? I said 2 hours, didn't I? Boom, it works. Invalid return values nil, 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 nil. Nil, 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 you say. Interesting. That appears that it knows the maximum length and pre-allocates, which is actually excellent. So 1, 2, 3, 4, 5. 1, 2, 2, 3, 4, 5. Okay. I'm down. No way. No way. I like how I'm getting the output. Yeah! Okay, so contains point false, contains point Lua, true. So then I press R and it doesn't crash the game. Is there a stutter? Huh. It just doesn't care. It just does. It simply does not matter. You can create you can spawn an entirely new Lua context from scratch, initialize it, make all sorts of stuff, and it's like, okay, well there it is. I am now comparing the Lua code path to the Rust code path. So we should be able to see some differences. This is actually really cool. Which ones were spawning inside of objects? I think this one does. Hup, hup, hup. Okay, it says it contains point false. So presumably, okay. So it is calling the function and then determining that it is not inside. That's really cool. That's so cool. Wow. Dude, I could literally just run the physics on Lua. False. I just didn't know how to do this, I guess. Oh yeah, my unsafe trick is working as well. I know lifetimes. I understand what's going on. It's so good to understand. This data must outlive that data. So it's not calling there. Or it might actually be calling there, and I just don't know because it's so quiet otherwise. Are there any that do spawn inside? I don't know. False. False. Okay, basically, I should probably lazy lock the Lua context and load the file dynamically at runtime so that I can edit the Lua file instead of having to rebuild the project every time. I want to use a new Lua source. Probably a good idea. Hey, worked it. Give you a ticket. Oh. Okay, so what is a map where you do actually spawn inside an object? Okay, so clearly the algorithm is working differently than the Rust algorithm. So I may be able to get some information out of it, as I'll be able to interrogate the runtime and inspect the values and see why it works and my code doesn't work. Why am I not excited to do that? I just wanted to have worked already the first time. And I'm like, And I did all this work to like be able to debug it, and then now I'm like, what? It's so cool. It just makes a whole new Lua. It's like, oh yeah, that's a new Lua. It's using like the vector things too. Like I converted it from vector 3 to Luau vector, which I didn't actually know how to use until today, which speaks to the quality of the library that I can just do that. Like actually Luau, oh, I reset. I did not want to do that. Well, we can see that it's printing true here, which I believe is correct. Even with the 0 exit radius. Great job. Great job. Okay, so I think I'm gonna lazy lock this. Lazy lock. Read stdfs read to string, and then result. We do not care. Org, and then lazy lock. Oh. That dude is using RC. Single threaded lock. How? Oh, obviously. RC. Oh. I could literally just read the file every single time you run the function. I mean, clearly the Lua loading is like fast enough. Okay. I'll just do it a different way then. Load source wants XD. Okay. So now every time I run this, or every time I restart the game, it'll load the file once. I could like pass the lifetime all the way down, like a reference and whatnot, but like this is easier. Arcane, and it's in. True. Boom, 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 boom. Okay. Okay. Okay, so now if I add a print statement here, print, and I run it again, there it is. Loaded from file. All right, so before I litter the code with print, I kind of want to like commit it. So give me a second. We go. Huge. All right, good job. Huge. Oh, coffee. amazing. What happens if I say this is a const? So on the surface, static items assume. Okay, before I read it, from what I've heard, static is a memory location, whereas const could also be a memory location, but the compiler has more freedom to choose to inline it into your code. Whereas static is like forced to be a memory location. Both contain a value, blah, blah, blah. Both contain a value, both require type annotations, both only initialize with the constant functions of value. How static are notably different that they represent a memory location. That means that you can have references to static items and potentially even modify them, making them essentially global variables. Static items do not call drop at the end of the program. Oh. There are two types of static items. Fascinating. Okay, so literally const would also work. So it's sort of like static lives in some region of memory that's like part of the program that initializes, and then const is more likely inlined into the function. Constants are inlined wherever they're used. Identical to simply replacing the name of the const with its value. Oh, they are always inlined. Static variables point to a single location in memory, which all accesses share. Okay, that is very simple. They can't have destructors and act as a single value. Screaming snake case. Okay, well, okay, so const is always inlined. Static is never inlined. That makes it very easy. So in this case, actually, it actually just doesn't matter. Kind of. Because I only use it once. There's only one usage of this value. So the fact that it's inlined, it actually just doesn't matter, whether it's static or const. And the only difference is that it gets cleaned up at the end of the program. Or maybe the compiler will clean it up when it knows it'll never be used again. Because I know that types have lifetimes, which is interesting. The types themselves. So you can have a type that only exists for a part of your program, which is wacky. I think I'm going to leave it static because, like, I want to. Okay. More coffee. More coffee. Oh, caffeine. I gotta do it. Print. Print. Paw print. Put it. It's not hard. Just do it. All right. So at the beginning of the for loop, print direction. Print direction. Why don't I do like direction equals direction. Oh, that has nice syntax highlighting. Yeah. Okay. So wait. Or okay. Okay. Yeah. Go for it. We build. We build. We build it. We build the source code. Okay. All right. I need a Lua Rust separation. No, I did that. Rah. 17,425. Fast fail false. False false. New direction false. False false. Direction false. False false. Direction 0. And then it hit the case. Okay. And then this one is like, and then it just like, all right. So this is like 9 billion compared to this. But like the signs are the same. Look. Same sign, same sign, same sign. And then it went cond equals to the true. But the what? But the false. But the what? So I believe this is also wrong. Excuse me. Okay, so yeah. Yeah. Okay. Um So we already know what direction is. Um I'll just D. Okay, so then on this code I go like, hi, I'm fast fail. Okay, so we got oh. What? Shadows D. Oh. I don't know, I guess that's actually okay, but so direction is printed here. Whatever, I'll just like do it. It doesn't matter. I betcha it's just gonna be like totally different. I betcha it might like the offset could be. I have no idea. I have no idea. Like I just don't expect it to fail. Okay, so looking at oh dear, looking at this, direction. Oh, this. Oh no, this is the second one in Lua. Okay, Rust direction. That looks like the same signs at least. Okay, fast fail true, fast fail false. So next point is 18 minus 18 25. Next point is minus plus minus. This is plus minus plus minus plus minus. So this dot is negative, this dot is positive. Totally different. Shui. So this said 17, 18, 6. So those are just like not the same. Oh, it has debug and display. Can I just display? Oh, okay. 4649. So this looks like straight up inverted. 2572, 2576. Does it not just look straight up inverted? It's an interesting dot product where it ends up at 0. How, why, what? Huh? Vert next point. PQQ minus P. Vert 0, 1. 1 is negative. Wait, negative, negative. 1 is positive. That's correct. 1 is positive. What? Q minus P. Okay, that is a very early failure. What if I just flip it and just like run it like that? Whoops, fail true. Okay, it just didn't work. Oh. Okay. Why is the direction so different? Q minus P. Mm. Okay. Look at that. Look at that. Initial axis. Initial axis. That's what I'm talking about. But then, what is up with that? Next point 1825. What happened? So the initial axis was exactly the same. But then degraded from there. Why? Vert point, mesh vert point, pause. Am I stupid? reduce. Huh? Okay, need more printing. Ugh. So it does call reduce 1. Both of them call reduce 1, and they get different values. This is a dead simple function. I am wondering how I messed this up. Okay. It is this function right here. It prints this out. We grab the vertex position, which is mesh 1 minus mesh 0. We add on the relative point and then negate it. This is just negative a. That's just exactly the same thing. This doesn't proc return. This math is wrong. There is 2 lines of code. What if I say this? What happens? Okay, what if I say this? What happens? I'm guessing now. Ah. Okay, so now it is completely flipped. Why? This is good progress here. Interrogating the runtime. So A0, A1. How do I fail at such basic code? It's P minus Q, 1 minus 0. P minus Q, 1 minus 0. P minus Q, 1 minus 0. A0, A1, 1 minus 0. Q, oh, I said it wrong. Q minus P. Yay. Twitch gamification. I'm not a fan of Twitch. Congratulations on your gamified experience. Q minus P. P is 0, Q is 1. Mesh 0, mesh 1. Look at this. Minkowski mesh. Mesh 0, mesh 1. P, Q. Q minus P. That's mesh 1 minus mesh 0. This has been obvious in my head the whole time. Fart vert. Vert is 0, 1. 0, 1. What? So this math is correct. Okay, we got that math. we at least got that math. So does it start wrong? If I check this out, is it wrong? Because that's kind of what it's looking like here, is that it's just wrong everywhere all the time. Okay, reduce simplex direction. 0.1. I'm struggling so much to see how this is wrong and how I'm getting a negative result. So look. So here's the Lua. It goes, yes, numbers. 0.04 minus 6. Here's rest. 0.04 minus 6. It's the same numbers as right here. Okay. Direction, negative 17.4. Lua, 17.4. It's the same numbers, but negative. It's running this reduce algorithm. Okay, I need to annotate the algorithm. All right. As painful as this is, I have to annotate the algorithm. P. It's just literally backwards? Negative. P positive, Q negative. P negative, Q positive. I do not see it. Like this is basically the lines of code that I'm comparing to here. One minus zero. If we go look at this definition, how does anything work in this entire game? Oh my god. Bug. Like if I change this right now, the entire game breaks. Let me do it. I'm just going to fall through the ground. Watch. There it is. The entire game broke. Wow. Very strange. Oh, that's so weird. I wonder why the whole game broke. Maybe because it was broken from the beginning and it was designed around the broken design? I am flabbergasted. Where else do I make this assumption? Do I flip-flop on the assumption everywhere all the time? I've repeated it countless times. 1 minus 0. So like we're doing 0 minus 1. Vert plus. D. 1 minus 0. I don't know. I just don't know. Like, there's just no way I write something like that without intending it. Just got here what was broken. Everything. This is like the entire game depends on this code. And I was writing code as 0 minus 1 2 years ago. And now I assumed that it was 1 minus 0 in all my other code. Does push solve assume this as well? Contacts. There's no meshes. Like, look at this hint point. Minkowski hit point. I probably wrote it as 1 minus 0. 1 minus 0. There it is. Hint point. So this is new code that I wrote 6 days ago. And I've been assuming... Oh, look. No. Okay, this is the code. I put this right below this and didn't notice it was 0 minus 1. Seriously? 0 minus 1? Like, what are you thinking? I can't like understand this code and know if I was assuming that the whole time. It's too complicated. This is stupid. It's not related to what I'm doing right now. Oh, I wrote the whole algorithm like this. I have no idea what the blast radius is for this change. What is the hardest part about this bug? I've been working on the same bug for a year. Like everything about it is hard. I'm currently designing a new algorithm to replace the old algorithm instead of fixing the bug in the old algorithm, which is the right choice because it was bad, brittle, and slow. Now it'll be good, robust, and fast. So what does it affect? That's the problem. I have no idea what the blast radius is. I don't know when my assumptions changed. I guess I'll swap the hint point, for consistency. because like I literally cannot change this because everything in the game depends on it. Make hint point consistent with vert. Oh, God, I must have just seen this and be like, oh yeah, it's your man. I guess I'll just find all the call sites and go for it. Literally D. All of these negative, and then see how that goes. Hint point as well, actually. Also, this changes back to how it was before. That's insane. God, I'm just gonna have to remember everything about making this. It should just be that. Okay, it's still busted. Why is it busted? It never runs. Oh, it says whoops. Next point negative. Okay, the direction is busted. Did I not? So am I stupid? Am I stupid? Am I stupid? Hold on. Model. Okay, so is my assumption just totally wrong? Everywhere all the time. Contains point. So is that point also negative? Like, do I just like negate the point, sending it into the function, and go negative negative? I don't know. At what point do I have to stop rethinking my entire program? Where does it end? I don't know. What is this? Who did this? Body dot position. Okay, so look at this. So model hitbox. It says 0, 1. So this is 0 minus 1. That is just completely wrong. but that's the order I'm using. So like this looks like I assumed 1 minus 0 here, because then the body position adds to model 1. So this is wrong. So the assumptions are baked, the backwards assumptions are baked into the fabric of the Minkowski mesh query operations. Okay, what about the other one? There's 7. 0, 1, look at that. Platform mesh, hitbox mesh. I'm assuming 1 minus 0. H1, H0. Why would it be 0 minus 1? That would be dumb. And yet it is. It's everything. There is no blast radius. It's just the entire thing is wrong. What does this have to do with the bug of falling through the ground? No, but that is what I'm working on. This is like the logic is inverted. There's a negative sign everywhere. Parts of the program are assuming 0, 1, and other ones are assuming 1, 0. And I don't know which is which. Like these all seem to be oriented 0, 1. But then it internally it's 1, 0. Which one is assumed more? I think the wrong one is assumed more. So the code here, this worked because I made the correct assumptions and included that in the transformation in the query function. So I made P mesh 0. Q is mesh 1 plus the point. So this is completely 0, 1 oriented, where it's mesh 1 minus mesh 0. But then that's flipped on its head in here. So literally, I need a minus sign on the whole thing. I need a minus sign on this as well. Why don't I could just do that. I could just put a minus sign here and then implement some stupid thing to swap it. It's already doing that, but okay. It's potentially going to exercise more of the code now. Nope, it just still fails. It's still wrong. is the problem with having different assumptions throughout the program, is I don't know where the flips are. It's off. It's just off by a little bit. It's only off by 4,000. Like, where else did I put a negative sign? It's not right there. It is right there. Can I just do 0, 1 with negative point and just remove? I don't know. I don't know. Oh. I try so hard to be consistent. If I was put in the same situation again, would I make the same decision? The answer is no. It just seems so obvious. Obviously, it's mesh 1 minus mesh 0. And yet, 2 years ago, it was mesh 0 minus mesh 1. I have to change it because at some point I'll forget the assumption and I'll change back to mesh 1, assuming mesh 1 minus mesh 0. If I leave it as 0 minus 1, I'll forget and then I'll go, oh, yeah, no, it's obviously 1 minus 0. And then I'll have the same blast radius all over again where I'm just writing new code that's wrong. I mean, I guess it's kind of hard to write new code that's wrong. So I guess all of my new code is wrong and all of my old code is right-ish. I'm getting mad. Okay, so point is 1 minus 0. So no, I don't actually need to do negative point. Point is 1 minus 0. So as long as you do negative everywhere within the algorithm, that should be it. Wait. -0. I don't know. Just go. Do we get more rust? Oh my god, we get more rust. Finally, it has actually passed conditions. Oh my god. Okay. The rust actually thinks the same thing as Lua. R. True. Rust and Lua are in agreement. All right, let's look at the internals. Initial axis, those look the same. Direction, 17.4.25. Yeah. 17, -4.25, those are the same. Fast fail false, 18, 18.25. 18, -18.25. 1074. We got the same numbers. I have understood something. 24, 23. Float is off by 1. Holy. That's insane. So these calculations are guaranteed to be more correct than the floating point ones. They don't lose any precision. Float is off by 1. But it still gets the right answer because it's not that vulnerable to the floating point curse. Reduce 3, reduce 4. On escape. Insane. Well, there it is, folks. Algorithm fixed. All I had to do was make everything negative everywhere. Negative. I need to write unit tests and stuff. So I think that the next order of business, that was really good debugging work. Like creating a Lua VM in order to debug the Rust code that's a port of the Lua code. Oh, you want to see what the difference is between the two pieces of code? Run them both. Amazing. Really good work by me today. W programming. Yeah, just spin up a Lua instance. Just embed Lua into the Strafe client. It's literally running Lua. Not right now though. It's running pure Rust until you teleport, and then it creates a Lua VM and calls the Lua function. Teleport. It called it. Actually, no, it didn't call it because I didn't try to teleport inside of anything. It only calls it when I try to teleport inside of something, and it's like testing to see if I'm intersecting it. It's a very small part of the game. At this point, I can use the same algorithm for initializing the main algorithm that runs everything, which was my plan from the beginning, to use this algorithm to initialize the sweep algorithm. So previously what I was doing is using the sweep algorithm to initialize the sweep algorithm, and the sweep algorithm can do that but it like has so many edge cases, and that's like why you were falling through the ground a lot of the time, is because as it was initializing, all it needs to do is find the closest point on the hitbox to the mesh. So there's some point of closest approach. Like imagine there's the mesh that you're jumping on and there's the hitbox. And so like it just has to find like, oh, that's the closest point between these two meshes. That's its job. But what it's doing is it's going like, all right, imagine this mesh is out at infinity. And as it comes in, we're tracking across the surface what's the closest point as it comes in until it actually reaches where you actually care about. So it's doing all of this extra work, tracking the mesh in from infinity, just to initialize it, to then go like, and then it's done. So it's a waste of computation. Instead, what it should be doing is running this new algorithm that directly finds the closest thing. Instead of using this like hack that I invented off the top of my head 2 years ago, it is an actual algorithm that just gives you the answer. And it's simpler, more robust, and faster. I think this is gonna work. I'm gonna have to do a lot of checking. I guess I just like make like unit tests and like I have unit tests, so I'm pretty good on that front for the physics. Oh. Popping in briefly, where are you at in what you just described? What did I just say? I have no idea what I just said. I was talking about the how the algorithm supports the other algorithm. So there's two algorithms involved here. There is sweep, where it's like this mesh is going and it's trying to find the time of collision if it's just the mesh is moving. That's the sweep algorithm. It's like tracing the closest point across the surface of the mesh as you sweep a point through space. It's like, oh, this is the closest point on the surface of the mesh as it goes by. That's the sweep algorithm. And then the minimum difference algorithm is as I described. Where are you at in what you just described? So previously I only had the sweep algorithm. But I'm adding in this other algorithm, which I didn't realize was exactly what I needed. It didn't look like what I needed. But yesterday, or was it the day before, I realized that it is actually equivalent to another algorithm and is exactly what I needed. Excited for no more falling through the ground. Unfortunately, this is just one of like 10 different ways you can fall through the ground. But this is really good progress. I think that this is going to increase the robustness, and I can move on to working on more physics bugs rather than just bashing my head on the same one for an entire year. I wasn't working on it for a whole year. Like, just whenever I came back to working on the physics, this is what I was trying to fix. I haven't fixed it yet. But yeah, as of the beginning of this week, I had a clear path to actually fixing another physics bug. bug fixing what's going on. Look at this. So I found the bug. Okay, so we have a Minkowski mesh. Wow, there's mesh 0, mesh 1. Wow, there's 2 meshes. Wow. So in Trey's code, he has query Q and query P. So P is mesh 0, Q is mesh 1. We're doing mesh 1 minus mesh 0. 1 minus 0. 1 minus 0. Cool. Great. Wow. That's how it works. Query P, query Q, Q minus P, 1 minus 0. In the model code, in the implementation of mesh query for Minkowski mesh, I have, when you get a vertex, it is mesh 0 minus mesh 1. Completely backwards. So all of the code in Strafe Client is using this 0 minus 1 assumption, but the new code that I just introduced is using a 1 minus 0 assumption. So the bug is written into the fabric of reality. So there's sign flipping this whole time. So you can see this is Lua execution, initial axis -337, Rust initial axis -337. They have the same numbers now. I actually embedded a Lua VM into the Strafe client. It's actually not that hard to do. Lua is very portable. So this is initializing the Lua runtime with the source code. I just read the file. And then this is calling the Lua code. So I have to like make the lifetimes go away and then call. And then all of this is like an interface between the Rust and the Lua code. So then this is the function I'm calling. Here it is. So I made the interface the same for the Rust and the Lua code. And they are agreeing now. After difficulties. Look. Minus sign, minus sign, minus sign, minus sign. Just every single call site of this vert made it a minus sign, and now it starts working. Yeah. Has this noticeably improved any specific test cases, e.g. serfs? I haven't actually finished the algorithmic implementation. So there's two uses for this algorithm. So this is a general algorithm, minimum difference, but it has two uses. I can query to see if a mesh contains a point, or I can query to see what the closest topological point is to the mesh. And because I have a concept of a Minkowski mesh, I can also see whether two meshes are intersecting or what the closest points are on between two meshes. It is the same algorithm to ask if a mesh contains a point as it is to ask if a Minkowski mesh contains a point. That's the same thing as asking if two meshes intersect. Revelation. But I haven't implemented this yet. It's unimplemented. I haven't like worked out what the actual edge on each mesh is. That's the closest. And that's how you set up the sweep algorithm. So I'll need to finish this this implementation. Oh, Trey sent me a message. But It's coming along. The road ahead is clear. Yar. This is the turning point. This is the bug identification point. There's still lots of work to be done. Do we do any tests here? No, no tests. What's a map where you definitely like intersect an object when you teleport? Oh, I know. Is DE Dust. There's a wormhole. Oh. Ah! Talk transition blue stage. We could try that. Did I change any code? No. On escape. Lua, reduce 4, direction equals 0. So the Lua code actually just returns direction equals 0 as a default value because it's immediately thrown away. Whereas the Rust code specifically has an enum variant that includes no new direction because it knows it'll never be used. So that's at the, is this, no, this is Lua. So that's at the bottom here. So see this? It says simplex big reduce, and it becomes simplex small when it's reduced. It reduces into the smaller one. So you have a simplex, which is like an array of vertices, and you can, the array might be length 1 to 3, and when you push a new vertex onto it, it becomes length, so this is small is 1 to 3, big is 2 to 4. You just pushed one onto it. So then you do some tests, then you reduce it, and either the algorithm ends with a length 4 simplex, or you have reduced it to a length 3. What was I talking about? Right, right. How the algorithm is rustified. Right. Okay, so this is the Rust part. If we go to the actual definition of this function, you can see that this is always the like reduced variant. Reduce 2 and 3 will always be length 1 to 3. Reduce 4 may include the escape variant. You can only escape once you reach length 4. Okay, well, let's look inside. Reduce 4. Wow, there it is. So here it is. There's the code. So the origin is contained. This is a positive detection. It just says vector3.new 0 and returns it as a default value because it knows it's going to be thrown away. But there's no sign of that in the Lua code. I had to like figure this out as I was writing the Rust version. But then it didn't work because it was all wrong. Oh my. Okay. Just relax. Damn. Transition to blue stage. Blue. Teleport. Oh my god. All right, we're going up here. It's awkward to be up on half the screen. But if I do the full screen, it like destroys. What happened? Oh. Full screen. I get frame drops, right? Oh, apparently not. Oh yeah, no. It hates me. I wonder if there's like full screen optimizations that are like behaving poorly. Can't be doing that. I know the stage. Yeah. Nope, it doesn't do any intersection tests. It's pretty rare to have to test that. It only happens when you teleport, and it only happens when you teleport inside of something. And because it's like it's using the BVH to find nearby objects when you teleport. And if there's no nearby objects, it doesn't need to run the algorithm because you're obviously not teleporting into anything because nothing is returned by the region query of like, okay, what's nearby? What do I need to test? It's like nothing. It's like, all right, good. God. Is all of your geometry in one draw call? Maybe. Are you like debugging it or something? It might be. Are you looking at the FPS and why is the FPS not changing? 2K FPS is nice. It is nice, isn't it? Yeah. Literally, it just draws everything on every frame. And because the shaders are so simple and BHOT maps are kind of low poly, or like I guess Roblox maps in general are pretty low poly, it just like doesn't matter that you're just drawing everything. It would be pretty cool to implement occlusion culling. I would totally do that. But of course, this is one of the heaviest maps and I get 2000 FPS. So it's not the most pressing issue. I did put a lot of effort into efficient drawing. And by efficient drawing, wait, are those the right color? Are those always that color? Am I just imagining things? Is this like HDR? Is this washed out? My monitor is HDR, and I'm wondering if it's like interacting with the HDR-ness. And it's saying like, I'm HDR, but it's actually not. And so it's being the wrong color of red. I guess I can just go like this. No, that looks exactly the same. It's really, really good tone mapping. The monitor is in HDR mode, but it just looks like SDR for all the SDR apps. Very nice. Very, very good tone mapping. Hui, hui, ah! Yeah, the monitor is drawing in HDR. I'm streaming in SDR. OBS is tone mapping. Everything is working so good. I had like really good timing. Linux HDR only like happened in the past like 2 years or so. And literally like yesterday, NVIDIA dropped a new beta driver that I'm running now that makes HDR work without hacks. So good timing. Ah! Okay, enough about HDR. Draw calls. Okay, so I do instanced rendering and what's the other thing? Indexed the vertex indices. So instead of being how does that work? Instead of going like, hey, draw a mesh, here's a bunch of points, it goes, hey, here's a list of vertices of the mesh. Here is a list of polygon indices into that vertex list. So that's indexed rendering. But then instanced rendering is like, this box is the same as that box. So why would you need to have separate vertex lists and separate meshes for both of them? You just say, that thing, yeah, draw it over there. So I implemented both of those, and that is enormous speedups. Enormous speedups. I think that bhop, what's it called? Arcane. I think it was like 100 FPS, and now it's 2000. So just enormous. I did a bunch of work to try to get the big meshy thing, you know, the like amorphous blobs in bhop, Arcane, where there's like, you're going through like a green amorphous blob tunnel. Those things were super laggy. I had to like group them together into a big mesh. And so like the way that the physics is organized is completely different than the way that the graphics are organized. The graphics like aggressively groups items together. And like tries to draw similar items as one big mesh when they're using like the same texture and stuff. But there is no occlusion culling. There is very, very simple shading, and there's no what? Oh, damn. Why did I fall to the ground? Okay. I shut down now. Okay, wound down. I was like pretty angry. What time is it? I'm gonna have to leave in 2 hours. I'll be here. I'll be doing work. I can do it. I can fix everything. I made it all. Don't you worry your pretty little head. Oh. Doesn't this not have... no, this is a determinant. It doesn't matter. This matters. Did I see any whoops? Ever since I fixed the signage, the algorithms have agreed. Even though they print slightly different numbers, it's working real good. So I think that tomorrow I will try to do the second algorithmic usage to like pull it into the core physics and use it to actually set up the sweep algorithm instead of the like sweep in from infinity method, which is just so lazy. But like, it was the right thing to do at the time because I only had the sweep and I didn't know that this was the solution to the problem. I might make it. We might make it. Maybe Strafe Client physics will be fixed. Maybe we'll be able to surf by the end of the year. Things are looking up. I finally found an approach. All right. Let's see. Yeah, I'll just fix it tomorrow. Um, yeah. I think that this actually doesn't need to be a negative here because it's a determinant, and doing the negative of the determinant and testing if it's 0 is still going to be 0. So, but here, those ones specifically matter. It matters. Oh boy. Yeah, okay, whatever. The last point, I think that's stupid stuff. Next point, I don't do it here. Does this one have one? No. I think that's it. GG's. And then this is just comments and like printing. Or basically just printing. Oh, and does the fast fail trigger? I guess not. Yeah, so contains point is now a functioning piece of code. And I need this one to do its job as well. And this is a huge algorithm, but I might be able to figure out a way to make it like not huge. Yeah, working. I'm gonna end the stream. We got to the core of the problem of the new algorithm, and it was just a sign mistake. It's an upsetting sign mistake because the problem isn't the new algorithm. The problem is all of the existing code. So that would be a lot of work to fix the signs and shake out all the bugs that happen. But doable. But yeah, there's a clear path to having robust collision calculation and initialization. This is the algorithm that does it. I did not realize how general it was. I thought it was an algorithm to determine the minimum distance between the minimum difference. That's what the algorithm is called, between two meshes. But really, it's a general algorithm to find the closest point to a single mesh. And then that is equivalent to finding the minimum difference between two meshes when you input a Minkowski sum. Cool. Did not know that. Found that out this week. Okay. Well, goodbye. I'll be back tomorrow, probably, and try to negotiate the code into a working state. So it's very complicated. There's a lot to do. We'll see how it goes tomorrow. But today went awesome. Goodbye.